Hello and welcome to the complete CSC guide. I am Sanskriti. So today I am going to tell you about the OSI model, which is a very important topic in your data communication, that is your networking. And this OSI model, they have some layers. There are 7 layers in the OSI model, which we will study one by one. Okay, and I will tell you some simple points which you can understand as well as you can memorize, so that in examination purposes you can easily write those things. Okay, so some important points are there which you have to understand, as well as you have to keep that in your memory. Okay, so first of all, what is the OSI model? OSI model is Open System Interconnection. That is your Open System Interconnection, right? So this one is OSI, and this model is layered framework for the design of the network, that is system that allows for communication across all types of communication system. So these are used for the purpose of communication system, right? So OSI model basically have 7 layers, and these layers, what they have, each and every layer, they are functioning in different modes and for different forms of your data, right? Somewhere it's about the beats, somewhere it's about the frames, somewhere it's about the packets. So each and every place you will see how the data is being communicated between networks, right? So how this is working, sometimes when the data is being communicated, it is within the network, within a particular network. Sometimes that is going outside the boundary of your network. So each and every time whenever we are going to discuss about these layers, you will see that each and every layer, they have some specific function and they are working on some specific background, that is whether they are working on a particular network or beyond a particular network. So you have to see each and every layer one by one, and they are written in a same sequence, right? So you have to take one by one layer and you have to see each and every function of the particular layer, so that you will not forget anything. Okay, so first of all, what we will see, that each and every layer, they have some function, right? So first one layer is your physical layer. First layer is the physical layer, right? Now it is responsible for the movements of individual beats from one hop, that is node, to the next. Here we are talking about a particular node, that is your hop. It's called as hop, from one hop to next. That is one node to another node. So physical layer, when you are working with the physical layer, we are basically working with the beats. What we are working with? The individual beats. Here the data is in the form of a beat, right? So these beats, when they are, this is responsible for the movements of the beats. Why? Because physical layer is, whatever communication is done, the data is basically in the form of beats. And what is the thing? It is from one node to another node. It's working from one, it's going from one node to another node, that is one hop to another hop. It is the responsibility of your physical layer. It is basically responsible for the purpose of the beats only. So from one hop to another hop, the beats, when they are moving, so this particular movement, it is responsible, the physical layer is responsible for that movement. Now what kind of work it is going to do? It is responsible for the movement of the beats from one hop to another. Now what kind of function it provides to these particular beats, right? Now first one is the physical characteristic of interfaces between devices and the transmission medium. Here, what will be the interface? In which interface it is going? The physical interface. It is basically working on the physical character of the interface. What kind of interface is going to be there? So, it is basically the function of the physical layer to show what kind of physical interface is being used here, right? And the second one is interface between devices and the transmission medium. What is the transmission medium? Which kind of transmission medium is going on when from one hop to another hop the particular movement of bits is going on? So physical interface between two devices and a transmission medium. What kind of transmission medium is going to be used that particular thing is the duty of your, that is the responsibility of your physical layer. The function, physical interface between two devices and your particular transmission medium. So whenever you are going for the physical layer, this particular function is the first function of your physical layer. Then now next one is representation of beats. Here what is happening, whenever we are talking about the beats, what we are doing, when we are transferring the beats, obviously that will be encoded in some kind of signal, that is encoding the beats to signals. Now what kind of, it can be a electric signal or optical signal, what kind of signal the beats are going to be transformed to, they are being encoded. Why this encoding is done? This is done because suppose if I am going to send you some particular message, right? So I have to encode that one, so that in between, if someone gets that particular message, he or she cannot know what thing is going to be transferred, right? So that we are going to encode that thing. Again, the second one who is getting that thing, the receiver, he is going to decode that message. But in this particular case, in physical layer, what happens, when the beats are going to be transferred, so you cannot transfer the beats in a beat format, you have to encode those things in a signal format. You are sending the signals, right? Beats, when you are sending the beats, that means what, you are not sending the beats in the same form, you are just encoding those beats in a kind of signal. That particular signal, suppose it's an electrical signal, optical signal, whatever signal, you are just encoding that particular beat in a kind of signal. And that time what you are doing, you are just sending that signal through this transmission medium. That is the first one, that is your physical interface and transmission medium. And when you are sending that particular beat in the form of your signal, that signal is being encoded and being sent through this transmission medium, and the receiver who is getting that particular signal, he is decoding that one in a particular beat format, and he is getting the total thing, whatever transmission have been done. So this encoding is done by this physical layer. So what type of encoding is going to be done, that is also being done by this physical layer. That type of encoding, which kind of encoding, which type of encoding is to be done, that is also function of the physical layer. So here what is the transmission, representation of beats and type of encoding of beats to signals, what kind of transmission had to be done, which kind of encoding had to be done, that is also a function of your physical layer. It's very important, right? Now these two done. Then third one is data rate. Data rate is also a very important thing. So this is also your function of your physical layer. So here data rate, that is number of beats sent at each second. At each second, how many beats are going to be sent? Because first one, we are getting the transmission medium. Next thing, we are encoding the beats while sending, right? Third one is how many beats are going per second. So at the rate, how many beats we are sending. So number of beats sent at each second, that particular thing is also being decided or seen or calculated by your physical layer. Physical layer, obviously, as I have told you, is working with the beats. So obviously it will take care of the beats only. So it is seeing that how many beats you are transmitting at a particular second, that you are the sender is sending to the receiver at a particular instant, at a particular second. So data rate, that is your beats sent at a particular second, that is being you said as your data rate. That particular data rate is also being calculated by your physical layer. Then now next one is synchronization of beats. What is synchronization of beats? That is a particular clock is set which is synchronized, which is to be synchronized, right? So sender and receiver must use same bit rate. Why same bit rate? If I am sending you some data, you have to receive the data in the same rate. That will be balanced itself, right? If I am sending a data, okay, I am sending you data, but you are not receiving the data with the same rate, then some data will be lost. So this kind of thing had to be taken in account. That is, if I am sending the data in a particular rate, the receivers should receive that data in that same rate, so that no loss of communication or no loss of bits will be there. All the bits will be, as I am sending, you can receive that one. So this kind of thing is your synchronization. Same data rate should be maintained between the sender and receiver. So here you can see that the sender and receiver must use same bit rate, and the clock must be synchronized. The clock must be synchronized because if the clock is not synchronized, then obviously there will be mismanagement of time. So what kind of data I am sending, in how in a transmission media, which kind of transmission medium I am using, and how many, that is the data rate, how many data I am sending, how many bits I am sending per second, and each and everything is being taken account by the physical layer. Now this synchronization is also taken by the physical layer. That is, if I am sending the data at a particular rate, the data rate should be same for the receiver also, so that no mismanagement of time will be there. So this is also a function of the physical layer. So you can see that how important is the physical layer. It's the basic layer, the first layer of your OSI model, but it is doing so many work and it is very important also, right? Now this is the thing. So, and the clock should be synchronized. Why? If the clock is not synchronized, then mismanagement of time is there. Then obviously some data can be lost. Here data loss is not taken into account. That is, we have to see the data rate. That is, the data rate should be same for both of them, and the clock is also synchronized, so no loss of data is there. Now next one is your line configuration. We have studied that in your previous class also. You can see the video. That is the line configuration. What is line configuration? That is, either it's a point to point or a multi-point. So this line configuration is also seen by this particular physical layer. That is, point to point means from one to one. This connection is being done, and the whole transmission medium is being shared by these two only, the sender and the receiver. But no other person can go inside this particular transmission medium. At the they cannot transfer. The sender is transmitting and the receiver is receiving that one. The whole channel is being just it is just reserved for these two only. But in case of multi-point line configuration, what happens? There more than one sender and receiver can be there. So here more than one sender can be there. So each and every sender, they can share the channel at the same time. So this sharing of channel is done in the multi-point. But in case of point to point, only one channel is being reserved for a sender and receiver only, for one sender. So this is what is there in your point to point and multi-point. So this line configuration is also being taken account by your physical layer. Physical layer sees these things also, right? Now next is your transphysical topology. This is also what we have done in our previous class, the blueprint, how the network is going to be set up. So this thing is also done by your physical layer, the physical topology, how your network is going to be set up for the communication. So there can be mesh topology, there can be bus topology, there can be star topology, there can be ring topology or hybrid topology, anything, or tree topology. So these kind of topologies are also done by your, they are also set up by your physical layer only. Since it's the basic layer, so obviously before sending anything, the blueprint have to be made. So this topology, your physical topology, whatever network topology you are going to use, that thing is also done by your physical layer. It will decide whether you are going to take the mesh topology or you are going to take the star topology. So this thing is also going to be taken by your physical layer only. Then now next one is your transmission mode. What is the transmission mode now? In transmission mode, what happens? There is a simplex, duplex, and half duplex and your full duplex. So these are the basically transmission modes in which the transmission is going on, right? Whether it's a simplex, only one to one is happening at a time, only a sender is sending, a receiver is receiving. Half duplex, sender is sending, only one sender at a time, one is sending, again receiver is receiving. And full duplex, they can many can do in the same time, right? So these are the basically the transmission modes which are being used by the your physical layer. So it is also done by your physical layer only. Physical layer do this kind of transmission. Which kind of transmission mode is to be used, that is also taken account by your physical layer only. Okay, now next is your, so these thing are what we are going to see, that these thing are being done, these functions are being done by your physical layer, the first and the basic layer of your OSI model. Now next is, so here was the main thing was your bits. Then now next is your data link layer. It is also very important layer in your OSI model. So here what happens, we are now working with some other features. Now we are working with the frames, right? So now we are working with the frames. Here we were working with the beads. Now with the frames. Frames are what? This is the, so this layer is basically responsible for moving frames from one hoop to another hoop. Here also from one node to another node. Now your data sequence, what we are sending beads, now you are working with the frames. Now what we are going to do in this case? So obviously data link layer also have some functions which is important when you are working with the frames, right? So those were the function for beads. Now the second layer we are moving upwards. Now it's for the frames. Done. So what is for the frames? Framing. First thing which comes as you are working with the frames. So obviously the first thing which will be coming, that is your framing. The first function is your framing. Now dividing string of beads to frames. Now I was sending the stream of beads, right? A beat sequence was being sent or transmitted from one to another. Now what is happening? Now we are working with the particular thing, that is your frames. So dividing these stream of beats into sequence, small sequence, that is your frames. Now this particular division of the stream of beats to these frames, that is called your framing. That particular function, framing, is being done by your data link layer. That is the second layer of your OSI model. So framing is basically nothing but it's the whatever division, whatever transmission of bits you were doing, the sequence of bits or the stream of bits which you were sending, you are just dividing these bits into frames, small frames, right? So this is what is being done, dividing the stream of bits into frames. Your framing is being done by your data link layer. Next is physical addressing. That is, what is the physical address? There are two kinds of addressing, physical and logical. So this physical addressing is being done by your particular network data link layer. That is, same network adds header to define sender or receiver. Suppose I am in the same network, I am sending within the same network. So what I will do for adding a physical layer, a physical address, what I have to do, what the data link layer will do, that will add some header to define which is a sender or which is a receiver. So to define a sender or receiver, to differentiate between them, what the data link layer do, it provides a physical address. That is, your physical address is being provided. So how it will provide it? Within the same network the communication is going on, then it will add a header to the sender or receiver so that they can understand whether it's a sender or whether it's a receiver. So how you can understand someone? By their address. So where he is living, if you want to send something, so the address is important. So this physical address will show you that whether it's a sender or whether it's a receiver. So adding a header will be done. So whether it's within the same network. So if it's within the same network, then it is having a header only. If different network, then receiver address connects to the network. Next one, that is for the next hop, what will be done? The receiver address will be taken into account. With the help of that receiver address, that next communication will be, next node communication will be done. If it is within different network, if within the same network, then a header will be added for this physical addressing, and if it is within different network, then the receiver address will be the address which will communicate to the next node. So this physical addressing is also being done by your data link layer, right? Now, next is your flow control. What is flow control? So here, when we are sending the bits or we are sending the frames, so what we have to see, data absorbed by the receiver. When I am sending you something, so if the data is absorbed by the receiver, it should be less than the data produced by the sender. If I am sending you, suppose I am sending you data, right? So if 10 frames have been sent to you, then your rate should be less. Your rate should be 9, so that whatever frames I am sending, again there will be scope of getting the next frame. But if you are receiving more and more, but I am not sending at the same rate, so obviously some miscommunication will be done. Some frames will be lost. Here what we have to see, that whatever I am sending, the receiver should receive lesser than that one, right? So I am sending you, there will be a scope that no particular frame will be lost. You have again a time sequence where you can get the next frame. So of all time we have to see that the flow should be controlled. What will be the sequence or what will be the formulas for that flow control? That formula will be the data absorbed by the receiver. Data absorbed by the receiver should be less than data produced by the sender. I am producing the data, but you will be receiving less than whatever the data had been produced. Absorption of the receiver will be lesser than the sender production, right? So this will be the formula which is used by the data link layer for doing the flow control. So that if I am sending so much data and you are receiving more than me, then obviously at a time there will be mismanagement, right? So I am sending you the data and you are receiving, suppose n data I am sending, you are receiving n minus 1. So there will be some space so that next frame you can easily capture. So no mismanagement will be there. So this is the technique how the flow of this particular flow control is being done by the data link layer, right? And next one is your error control. How the error is being controlled. If some particular data or some particular frames have been lost, then this particular data link layer, how it will do the error correction or error control. So it will detect and retransmit lost or damaged frame. So data link layer can easily identify the damaged frame or the lost frame. So what the data link layer they will do, they will first of all see that which particular frame have been lost or which particular frame have been damaged. There can be some damaged frames also, right? When I am sending you the frames, so obviously some frames can be damaged also within this particular transmission. So whenever there are some protocols are there, stop and wait protocol, some go back end protocol, we will discuss that later in later classes. But what happens in this particular layer, what happens, so these protocols are being used, but there are some techniques also. What the data link layer do, data link layer basically finds that it do the error control. So how it will do, it will find that whether some data frames have been lost or some frames have been damaged. If that particular thing have been done, then it will retransmit that data, retransmit that particular frame, so that no frame is lost. The sequence will be maintained. Lost frames or damaged frames will be, again first of all it will search that one. If it will get that one, then it will obviously retransmit that thing. Then so this error control technique is there in your data link layer for the particular frames, lost frames and your damaged frames, right? Now next is your access controls. That is what kind of access is going to be there, right? So how this access control is done? See, two devices connected to the same link. When within the same link, two devices have been there, gives protocol which device will control over the link. It will provide some, as I have already told you, some protocols are there. So it will provide you with a protocol, particular protocol, some set of rules it will provide, that when a particular link is being shared with by two devices, which particular device will have the control over the link, right? So that particular control, which particular device is going to access the link first, that thing is also being done by your data link layer. So this is called the access control. Obviously it will have which one is going to access first the link, or that particular control is also being done by the data link layer. If these protocols have not been sent, and if both of them are going to send, or both of them are going to access the link at the same time, so obviously mismanagement will be there, some lost frames will be there, some damaged frames will be there, everything will be just in a haphazard manner. So to control that thing, right, so what it is doing, it is doing a access control. How access control is providing some protocols, so that whenever a particular link is being shared by two devices, then which device will have the control over the link first, that at a particular time, that thing is also being decided by your data link layer. So obviously data link layer is doing a more matured work than your physical layer, since it's the second layer of your OSI model. So obviously the work, you can see that it's the more matured work what it's doing, the data link layer, more than the physical layer. And the basic thing is your frames, which is working on, it's the frames, right? Now so your data link layer is also done. These are the basic points which if you can memorize, or which you can understand, then you easily, if any layer is coming in your examination, you can easily write the whole thing about this layers, right? These are the basic functions, nothing else. Now next is your network layer, then the third layer. Now what we are going to work with, now we are going to work with the packets. Now next word, where in case of your network layer, that are the packets, right? Beats, frames, now packet. What are packets? So basically network layer is responsible for the delivery of individual packets from source host to the destination host. Now we are not talking about the nodes. Now we are talking about the source host and the destination host. Now you have a source and you have a destination. From the source, the thing is being transmitted, and the destination will get that one. So this transfer of these particular packets is being done by the help of this network layer. This is the third layer of your OSI model. Obviously the working of this layer will be more than the these two particular layers, right? So here what is happening, so basically packets are the main basic thing of this network layer. Now logical addressing, there we were talking about the physical addressing, now we are talking about the logical addressing. So obviously physical addressing, what we were doing, it was being done by your data link layer, same network, different network. Now we are talking about the logical addressing, right? So here what is happening, packets needs an address when passes network boundary, that is called a logical address. Now I am working outside my network boundary. So when I am working outside my network boundary, so there should be some address for the packets, so that they can be easily identified. To get identified, they have some address, and that particular address is called the logical address. So this logical address is being provided by your network layer, since it's for the packets, right? So for these packets, some network layer is providing some logical address when these are going outside the boundary of your network. Now this is being, communication is being going outside the boundary of the network, not within the network, right? So this is the thing that is called the logical addressing. So logical addressing is basically done by the network layer, and physical addressing was done by your data link layer. Done. Now next one is your routing. Now routers are also some internetworking devices which we have studied in the previous class. So routers are being used in this network layer. Okay, some routing table, they are provided, some routing tables are being managed by these routers. By that routing tables, each and every, whenever which device is going to transmit, whenever what thing is going to, what will be the next network where the particular thing, the particular packets are being going to be routed. So these things are being decided by these routers. So they are basically a very important part of your network layer, right? So these are the internetworking devices. Done. So what does router do? So routing, when independent networks or links are connected to create internetworks or large networks, right? So the connecting devices are called routers, which routes the packets to their final destination. So these are basically the connecting devices between two networks. So here you can see that what is happening when independent networks or links, they are connected to create internetworks or large networks. So when we are connecting some networks, the independent networks or individual links, when we are connecting and they are making a large network or internetwork, as I have told you, these are internetworking devices. So obviously these connecting devices are called routers. They will route your packets to the destination. Which destination you are just sending the packets. Now which destination will be for this packet? So these routers are just, they have some routing tables. They decide by seeing that by their IP address that which particular destination will be the destination for your particular packet, so that your packets are not lost, right? So this particular routing function is being done by your particular network layer. So this is also an important function. Then so the connecting devices are called router, which routes the packets to their final destination. The sender is sending, the router is getting these particular packets. It is getting so many packets. Now it is by this IP addresses, it is seeing the particular routing table, and it is deciding that to which particular destination it is going to route that packet, and it is sending that packet to that particular destination. So this is what is the work of your network layer. So you can see that whenever we are going upwards, the work is going also advancing, right? So here the logical addressing is done also, and as well as you can see that the routing is done. Now internetworking is coming to account, right? Now till now we were working on the networks. Now when networking layer is coming, so internetworking task is done. Internetworking devices are coming one by one. Till now we were working with the networking phase only. Now the internetworking phase is coming. So you are advancing layer by layer, you are advancing, as well as the function is also going to advance. That so this is what is happening in your network layer. Now the next layer, that is your fourth layer, that is your transport layer. So this is the fourth layer, that is your transport layer. So it is basically depending on the delivery of messages. So here responsible for delivery of a message from one process to another. Here process to process, now some process is being done. So this process to process transmission of the messages are being done by this transport layer. This is transport layer, so obviously some transporting, that is the message transport, whatever is done from one process to another process. So this thing is being done by your particular uh, transport layer. So here the thing is your delivery of messages, right, from one process to another. Here was the source host to destination host. Here it is from one process to another process. What it is transferring? The messages, right? So obviously it will also have some functions. Transport layer is also, that is the fourth layer, it is also having some function, but here the what is the working piece, that is your messages, and from one process to another process. Now here the main thing is your service point addressing. Computer runs several processes at same time. Since your computer have same many processes working together at a particular instant of time, so this service point addressing is being done. Why? This helps the network layer get each packet to the correct computer. That whatever thing is done, since each and every the network layer, what it does, what it just get packets to the correct destination, right? It to the correct computer. Here what happens, the transport layer gives the entire message to the correct process of the computer. So this service point addressing is very important. Network layer is sharing the packets to the particular computer. It is doing the same thing, but the transport layer is doing what? It is just transferring the messages to the particular process to process. So to do this particular thing, to do this transmission, what this entire message is being sent to the correct process. From one process your message is coming and it is sending it to the particular process, the correct process. So this is being on that particular computer. Since computers so many particular your computer is running so many processes together at a same instant of time. So the messages should be sent to the correct process from one process to another process. So this sequence should be done correctly. That is being done by your transport layer, and this particular transferring to the correct process is being called your service point addressing. What service is being given to a particular point. So this addressing is being done by your transport layer, right? So network layer is sending the packets, correct packets from within the same computer, and the transport layer is sending the message to the particular to the correct process in the same computer. So this is basically what is the work of your transport layer. Now second one is your segmentation and reassembly. So message, whenever you are transmitting, so bits, what we were encoding the bits to some signals, right? And we were sending that one. Then the receiver was decoding that one from one hop to another hop. We were from one node to another node. This was done. Now here what happens, here we are sending from process to process, delivery is being done. Now what is happening, when we are transferring a particular message to another process, what we have to do, first of all, it had been uh, segmented, that is it's segmented into different particular segments. So before transmitter, so they are transmittable segments. You cannot send the message as a whole. It is between the computers, and it is from one process to another process. So you have to segment that particular message to transmittable mode, to a particular sequence or to a particular mode, that is your transmittable mode. So we are just, message is divided into transmittable segments, and you have to keep one thing in mind. If I am segmenting something, suppose if I am segmenting anything like this, suppose this is my message and I am segmenting this message into transmittable segments, and I am sending that particular message to my receiver. But what will happen if this will be lost, or if some segments are being lost? So to just avoid that particular loss, what we will do, we will give some segment numbers to those segments. I am breaking the message into segments. This is my first segment, second segment, so in a transmittable mode, right? Transmittable segments have been done. The message is, this is my whole message, this is my whole message. I am dividing it into transmittable segments. I am dividing it into, this is one segment, these are different segments. So what I have to see, when I am breaking this to different segments, I have to number those segments, so that this segmentation I am doing, right? But when I am sending those segments to the another process, that process, after getting these particular segments, it will reassemble that thing. How it will reassemble? If I am not numbering those segments, then how it will reassemble? So what is happening? The message is divided into transmittable segments with sequence numbers, so that upon arrival to destination, they can be correctly reassembled. So this segmentation and reassembly is done by your transport layer. It's the function of the transport layer. Whenever you are sending the message, first of all, the transport layer, the process which is having the message, which is sending the message, it will break the message into particular segments, transmittable segments, which can be transmitted easily, right? So it will break those message, divide those message into transmittable segments. But before that it is breaking, it will number those segments. Before sending, it will obviously number those segments, so that I am just making the segmentation, so it's okay. But when I'm sending the segment to the receiver process, what it will do, it will try to reassemble that one. But before reassembling, how it will reassemble? If it doesn't, this process doesn't knows what was the message, right? If I am sending you a particular message and you don't know what is the message, so if I am sending you a message, then when at the time of reassembly, you have to know that, for how you will know that what was the particular message. To know that particular message, I have to make some segment numbers. You can see those numbers and easily reassemble the particular segments, and you can get the main message. So this is what that is done by the transport layer, so segmentation and reassembly. So this is the thing what is done by the transport layer. Now next one is your connection control. Now some connection is there between process to process, two processes we are talking about. So when this process to process connection is there, so this connection is being controlled. How? So connection less and connection oriented. There are two, there you will see some protocols also, UDP, TCP protocols are there. You will see that connection less and connection oriented. What will be the thing about connection less and connection oriented? I will show you. Just see. Whenever the sender is sending a particular message, in case of connection less, right? What happens whenever a sender, it is sending a message to the receiver. So this is my particular message which I have segmented, I have numbered, and I am sending that one to the receiver, and the receiver will assemble that one. Connection less is what the sender is sending protocol. Up to this sending, this segmentation, these all things, it's okay. After sending the message, the connection is connectionless, the protocol is not connected. Now whenever the receiver is receiving, if some particular frames have been lost, or some messages have been lost, some segments have been lost, so these kind of things, the connectionless protocol is not seeing that one. So this kind of connection is just doing the segmentation, sending up to sending portion, but after sending it is not responsible for what is happening. But in case of connection oriented, what happens? Connection oriented protocols, what will they do? This segmentation they have been sending, and whether something is, this is the sender and this is the receiver, so whatever thing is being up to the receiving portion, this particular protocol is responsible. So it will see that we segment, if some segment have been lost within the within this particular transmission, or some segment have to be retransmitted, some is damaged, so this particular thing is being seen by your particular protocol. So in this case what happens, the connection is oriented, the whole connection is uh, established up to the receiving point. But there what happens, connectionless, the it is the sending the message, and no connection is between the sender and the receiver. After that, this protocol doesn't work. So this kind of connection control is also being done by your transport layer. What kind of connection is being established, whether it's the connection less or it's the connection oriented one. So this is also being seen by your transport layer. That, so this is also a function, that is your connection control of the transport layer. Now next one is your, again, your flow control. There we have seen the flow control in your particular, where we have seen, here we have seen the flow control in the data link layer, and next will be in your transport layer. So here what is happening, here the particular flow control is being done end to end rather than in a single link as in data link layer. Data link layer, what we were doing, we were working with a single link, right? So there the flow control was done within a single link, but here you are talking about a particular processes. So here the connection will be, here the flow control will be done from end to end, to the first process and to the last process, up to the destination process, source to destination. So end to end flow control will be done there. For a single layer, single link, the flow control was done. Here from end to end, whole process, from first process to the destination process, whole flow will be controlled. So the flow of your messages will be controlled, segments are being controlled. Now next one is your error control. Here also the error control is done process to process. Since the transmission is done process to process, obviously the error control will also be done process to process. Same thing, but here the thing will be done process to process. This layer makes sure the message is transferred correctly to the destination without error. Data link layer was also doing the same thing. Here also it was doing the error control, but here the error control is being done, that was for the frames, and now it is for the process to process, the error control is done. And this next thing is, it will see that the message, whatever the segment, whole segments we are segmenting, we are it had been reassembled, so without any error this message is being transmitted. So this is the duty of your transport layer, your fourth layer. So these are the functions of your transport layer. Now next layer is our session layer, this one, right? So transport layer complete, session layer. Now what the session layer does, it is working for a particular session, right? For a, suppose a communication is being done, so for a particular session the whole function is being taken with the session layer. So here it is responsible for mainly dialogue control and synchronization. So here the dialogue control portion and the synchronization portion is being taken into account, right? So first one is the dialogue control. What is there? Two systems enter into a dialogue. It allows communication between two devices, either half duplex or full duplex. Either half duplex means the sender is sending, it is getting, the receiver is receiving, then it can tell, or one is sending, then the another. At a particular time, only one can use the particular link. But it's a two-way communication, but at a time, one can use the particular your transmission media, right? The particular link. But in full duplex, at a time, two can communicate. Both of them can communicate. So this is called your, that is your particular full duplex. So this kind of dialogue control is also being done by the your session layer. That is, if two systems enter into a particular dialogue, right? So it allows communication between two devices. Both the devices can communicate at the same time. Same thing, both are communicating, but what happens? The thing which is different, that it can be a half duplex, that is the whole your transmission mode or your link is being reserved for a particular device at a instant of time. It can, but a particular device can communicate, then when it is stopping, then the other device will be communicating. As you can see, you can tell about a walkie talkie, that one can talk at a time, then again another, when it is stopping, then another person can talk. So one is reserved, one total link is reserved for a particular device at a particular time. Then when it is stopping, then the second one can whatever, they can use the link. But in a full duplex, what happens, it's a telephone, we can talk on both sides, right? If I am talking, the person there, they can also talk at the same time. So this is what is happening in a particular full duplex mode. So this dialogue control is being controlled by your session layer. That's the function of the session layer. Two devices communicating, whether it will communicate as according to your half duplex or full duplex, these things, this management is being done by your session layer. Then now next is your synchronization, that is adding some checkpoints. Checkpoints where we add whether up to that portion some loss have been done or some damaged frames are there, some damaged packets are there. So some synchronization is being done, and the synchronization points to stream of data. If some stream of data is being sending, some checkpoints are there, or some particular synchronization points are there, that up to this point my data have been sent, and up to this point the data is perfect. After this point some data have been lost, or after this point some data have been damaged. So this particular thing, synchronization, is being seen by your session layer. It's the function of your session layer. So dialogue control and your synchronization. Checkpoints are within your stream of data, whether some data is, if lost is if some data is being lost within the transmission, how you will know that one. So some checkpoints have been provided, some synchronization points have been provided. By these synchronization points or by these checkpoints, you can easily understand that up to this particular point my data is okay. Whatever data I have sent, they have received that one. After that particular point to another checkpoint, if you see some data is missing, you can understand that yes, this data what I have sent, that is not being received by the receiver. So there is some error there. Then you can retransmit that data. You can easily maintain that loss. Okay, you can just overcome that loss, right? Or you can easily retransmit that data if some damaged data is there. So these checkpoints are very important. So this checkpoint is also provided by the session layer. Now what is the next layer? That is our sixth layer. So basically the two functions are only there, dialogue control and synchronization. Now for your presentation layer, now in presentation layer, it is responsible for translation, compression and encryption. Translation, compression and your encryption. These are the three functions which are being provided by your session layer, that is, presentation layer. Now, what is translation? Sender changes information to common format, receiver changes information to receiver dependent format, independent format. That is translation of your data. What is the translation? That is, sender is changing the information while sending the data. The sender is changing, it is in the sender format, right? So it is changing the data to a common format so that it can easily be transmitted in the transmittable format. So it can easily be transmitted. Now, when it is transmitting, the receiver is getting the data. Then receiver is doing what? It is translating the data in its particular format, right? Some interpreter type, like we are sending, whenever we are talking to another language, what we do? We have some translator with us. I am telling the translator, this is my sender form, my language. Suppose it's my language is Hindi. So if my language is Hindi, this is my sender language. Now I am doing it in a common language. What is the common language? So we have to understand in English. So I am telling that particular thing to that particular person. For him, I am telling it that this is my particular format. So I am changing that, I am giving that thing to the particular translator. It is changing that particular language to English and it is sending to the receiver, who can receive that particular language and receive that in its particular format. So a particular translator is there in between. Here what is happening? The sender is translating the data, whatever thing it is going to send, in the common format, right? Which is understandable by both of them. Then the receiver, what it is doing after getting the data, it is translating it to its own format, to its own language, receiver language. And the whole process, the translation is going on. So presentation layer, so this is a kind of presentation, how we are presenting the particular data. So this is done by your presentation layer, that is your translation of data. Now next one is your encryption. Again, encryption is done so that the data cannot be understood by others apart from your sender and receiver. So this encryption is done by your presentation layer. Why this encryption is done? So that if some data is being got by any other person in between, he or she cannot understand your data. So this encryption is also done. So the sender is encrypting the data and sending via the transmission link. The receiver is getting the data and receiver is decoding the data, right? It is decoding the message and this is done for your security purpose. So this particular thing is also done by your presentation layer. The encryption of the data and the decryption of the data, so that no security fault will be there, right? So this encryption is also done for your security purpose. Now the last one is your compression. What is compression? Important for data like text, audio, video, that reduces the number of bits. When I am sending, we have seen also that we are compressing the data while sending. So this compression of data is also done by your presentation layer. While some particular formats are there, some particular bits are there, that these particular bits can be transmitted, not more than that. So to make that particular, whatever message I am sending, to make that in a particular bit, that particular data, whatever I am sending, to compress that data in a format which is eligible to be transmitted. To make that format, we have to compress the data. So compressing the data to a format which is eligible to be sent, that particular compression is also done by your presentation layer. So presentation layer is translating the data. It is responsible for the translation of the data. It is responsible for the encryption of the data, as well as it is also responsible for the compression of the data. So three kinds of function is done by your particular presentation layer. Then now the last layer, that is your application layer. So application layer responsible for providing services to the user. It is the user interface layer. It is basically being made for the users, for the user interface it is working on. Then, so first thing is network virtual terminal. It allows user to log into a remote host. If the user wants to log into a remote host at that particular time, network virtual terminal, that is your NVT, is being provided by this application layer. So NVT is being basically provided by your application layer. So this is the function whenever the user wants to log into a remote host. At that time, this application layer functions. So it is basically made, or the functions basically whatever the application layer is providing, it is for the user purpose only. Up to this, we were working for the messages, for the beats, for the frames, for the data, basically the data. But here, it is this application layer is providing the whatever functions it is, whatever facilities it is giving for the user only. So first one is your network virtual terminal. Now next is the file transfer. Whatever file we are transferring, so this file transfer for the user, this application layer is responsible. Whatever file you are transferring, to maintaining those files, what kind of files have been transferred, what are being received. So this file transfer management is also done by your network layer. Second is access and management. So your file access, whatever file you are sending, to access those files, what kind of people can access those files, how to manage those files which have been sent. So this particular function is the function of your, which is being provided, which is responsible layer, that is your application layer. It is seeing the file transfer, the access, the management, each and everything is being seen by this application layer. Okay, now next is mail services. Emails we are sending day-to-day life, emails are very important whichever you are sending. So mail services are also being provided by this application layer, where email forwarding as well as the storage of the emails are being done by this application layer. The forwarding of email from which particular source it is being sent to the destination which it had to be sent. So this particular forwarding as well as the storage where the emails are being stored so that they are not lost. So this storage of the mails are also being done. So mail services are basically the function of your application layer. Then now next one is the directory services. Provide distributed database sources and access for global info about various objects and services. So for the global information, what is there, through access to your various objects and services, this provides distributed database sources. So this thing is also being provided by your application layer. It is providing the directory services. So the global information is being provided by the help of some database sources. So this thing is also being provided by your particular application layer. So you can see that up to whenever we are going layer by layer, you can see what are the different functions and how the data is being transmitted, in the what form the data is being transmitted. So in physical layer it was bits, in data link layer it was frames, in network layer it was packets, in case of transport layer it was message, and in case of session layer we were using the dialog control and synchronization. It was providing the dialog control and synchronization. In case of presentation layer, the translation, the compression, the encoding of the data. And the application layer is basically for the user purpose. It's for the user interface, right? So for the user interface purpose this is being used. So these are basically the 7 layers of your OSI model, and you can see that how these are functioning, how the data is changing the form also from one layer to another layer, which layer is functioning with which kind of format of the data. So these are basically the basic functions of all your different layers, and you can now easily understand that which layer is giving which kind of facility, which is responsible, which layer is responsible for which kind of which form of data or which kind of functions. So this is the main thing. Now apart from this OSI model, we have again another model which is the TCP IP model. The TCP IP model is also having this much layers only, but there the layers are being submerged to one and it is being taken into account, right? We have 7 layers. Here you can see same layers. The data and physical layer and data link layer are taken as one. The network layer one, transport layer one, and your session, presentation, application have been merged to one single layer. So you can see this is the TCP IP model. which is having each and every layer. You can see there have been some protocols, they are working for between some protocols are there, provided some protocols, right? So in case of physical layer and data link layer, they have been formed to one, they have been merged to one, taken into as a same layer, right? And protocols defined by the underlying networks, host to network. Now host to network connection is being done, and the protocols whichever is maintained for this purpose from host to network, so these protocols, underlying protocols, have been taken here. Now in the network layer, for the next layer which we are going to add is the network layer. This is the second layer in case of your TCP IP. Here the particular whatever your protocols have been used, they are the ICMP, IGNP, internet group messaging protocol, control of messaging protocol, internet protocol, your RARP and ARP, that is the address resolution protocol, the reverse address resolution protocol. So these kind of protocols are being used here in case of your network layer. Now in transport layer, you can see the SCTP, UDP, TCP, that is user datagram protocol, your transmission control protocol, and your stream control transport protocol. So these kind of protocols have been used in case of your transport layer. And the last layer, that is your session, presentation and application, these have been merged to one layer, one particular layer. Here also we are having some protocols which is maintaining these three layers together. These are basically the SMTP, simple mail transport protocol, again FTP, file transfer protocol. As you have seen here, the file transfer is done in case of application layer, so file transfer protocol is also taken into account. The HTTP, the DNS, that is domain name service, that is your SNMP, telnet. Okay, so these protocols have been used in case of hypertext transfer protocol, that is your HTTP. So these protocols have been working in case of this last your layer, in case of your TCP IP. So basically four layers are there: your data link layer and physical layer, your networks, transport, and these three: application, presentation and session layer. These have been merged to one. So these are the protocols which are working in those particular layers in case of your TCP IP. And this is what is there in your OSI model as well as your TCP IP model. The functions of the layer are same. Functions are not different, but these are in case of TCP IP protocol, but model, what is happening, there are some protocols which have been introduced, and these are the protocols which are functioning in these particular layers. So till today, whatever I have taught you, I hope you have understood these things. So this is what was there in your OSI model layer model. Okay, so these are the 7 layers and your TCP IP model. So you can easily understand, you can easily study from this particular thing whatever we have studied today, and it will be, I hope it will be helpful for your examination purposes. For next class we will have some next topic, whatever topic we will take from some, maybe some another subject, or maybe from this subject only. So if you have any comments, if you want to tell me anything, you can easily share with me in the comment section. Whatever subject or whatever topic you want from me, I will tell you that one. And till then, if you have any kind of queries, you can ask me. And if you like my channel, then please subscribe, and so that we can study more together. And obviously you can have, I hope you can have some knowledge from me, you can gain some knowledge from me. And you if you like, you please subscribe my channel. Till then, take care. Goodbye.